So this is lesson number 56, angles in circles and proofs. We're going to skip the proof portion of this and just do the angles in circles. And what we're going to do is look at some different circles. So let me get one on here and see if I have one hidden away in my math folder. Math, okay, there we go. There's my circle. Alright, so if I have a line through my circle, like that, that is called a secant. Okay, when a line goes through a circle. Alright, and if it intersects it in two places, the part of the secant that's inside the circle is called the chord. So that's just the blue part. The secant is the whole thing. And you get into the whole secant thing when you get into calculus, but obviously we're not going to be doing that. If we have two arcs, or if we have an angle here, and we have a major arc, and we have in red a minor arc, so we're just kind of going over some vocabulary there. And let's see here. Tangent is a line. Again, you'll be using this in calculus, but a tangent is a line that goes and touches or intersects that circle at one point, and that point that it touches it is called the point of tangency. Now I say that out loud while I'm writing it because you'll never figure out my handwriting unless I tell you what it is. So that's the point of tangency. Alright, so we've got our secant, we've got our chord, and we've got our tangent. And our diameter is a special type of chord that goes through the center point of the circle there. Alright, so anyway, let's do some things with all that information that I gave you. A long time ago, we talked about if we have a vertex on the circle and we have an angle. Okay? And that angle is called an inscribed angle. The measure of an inscribed angle will always be half of the measure of the intercepted arc. So if this is 60 degrees, this angle here will be 30 degrees. Okay? And we learned that, I don't even remember when, long time ago. If we have, let me get rid of this. If we have two lines that intersect inside the circle, okay, doesn't matter where they are, and what we've got here is these two angles are going to be the same, so that'll be x degrees and that'll be x degrees. Those are vertical angles, so they're going to be across from each other like that. And let's say that this is 40 degrees and this is 80 degrees. And we want to find out what the degree is of both of these angles. We know they're the same, but we don't know what they are. The way we do that is we take the arc here and the arc there, we add them together, and we divide by 2. So we take the average. So 120 divided by 2 is 60. So these angles in there are 60 degree angles. Alright, so that's if they intersect inside. Alright, let's look at some other situations here. If we have an angle that goes through here and does that. Alright, and let's say that we're trying to find out what that angle is. And let's say that's 40, like on the last one, and that's 80. Problem is, our angle, or our vertex of our angle, is on the outside. When they're on the outside like that, we're going to get 80 minus 40, because they're not inside, divided by 2. So that's going to be 40 over 2, which is going to be a 20 degree angle. So my x right there is a 20 degree angle. So if the lines intersect outside the circle, the measure of the angle formed equals half the difference of the intercepted arcs, which I have there. Alright, so what if one of those lines is tangent? So if I've got a line that's tangent, and then I've got another line that goes through here. So we're looking for this angle right here, and let's say that this arc is 60, my minor arc, which is that one right there, and my major is 120, which tells you then that this is a diameter because this is 180 degrees. But regardless, we still take the difference. We take the 120 minus 60, take half of it, and we end up with a 30-degree angle right there. And then that tells me this is 30, which tells me that this is going to be 150. So I can find out all kinds of information based on that. Alright, so let's look at one more, and that'll be it for this lesson, since we're not going to do the proof part of it. If I have a line that's tangent, and let's say I have a second line that's also tangent, okay, and this major is 260, and this is 100, exact same thing works. We're trying to find this angle. So 260 minus 100 divided by 2. It's going to be 160 divided by 2, which is going to be 80. Okay? So that's it. So if the angle that you're looking for is within the circle, like if I have this here, and I'm looking for that, we're going to take this plus this and divide it by 2, and that'll give us that. If it's on the outside of the angle, like this, we're going to subtract the major and the minor, and then we're going to divide by 2, and that'll give us that angle. And that's it for lesson number 56. So if you look in the practice problems, let's just kind of glance at those. The first one, they give us two that have the inside angles, and they give us the 80, and they gave us the 60, so you're going to add the two and divide. Alright, so when you get the next one, like, now let's look at D. We've got an angle here, and an angle here, and we're looking for that, and we're given this is 280, and this is 80. Notice that when we add those two up, we get our 360. Subtract the 2, divide by 2, and you get this angle right there. Okay, so not really too much to this. They've given you some of these circle laws, rules, guidelines in earlier lessons, and then they're just adding to it by doing what we've got there. Now, one of the things I want to remind you of, which I don't even know if they give it to you in this lesson, but let's go ahead and remind ourselves of it. If we have a central angle means the vertex is at the center point of the circle. If that's 60, this is going to be 60. If we have our vertex on the line like that, and this is 60, this will always be 1/2 of the 60, so that'll be a 30-degree angle. So just something from old stuff that we did, and that's it for lesson number 56.